Good morning, Peter, Muzale, and others. Good morning, members.
Morning, sir.
Okay. I hope you are doing fine.
Yes.
I believe the last time we met, I think we were not able to complete what we wanted, but nevertheless, we shall proceed slowly and hopefully you will pick up what is needed. So today, we shall start instantly, since everyone is aware that these lessons start at 9. Even if we have different challenges, they'll have to come and find us on the way. So we shall start from here. Please get a pen, piece of paper, and a calc. Then we get started. Inaki Mose, please rename yourself. We would like to know who you are, right from last week.
I'm ready.
Okay. Inaki, please rename yourself. You will induce me to send you to a waiting room.
Sir,
Yes, please.
I went further on calculate the number of moles for a given mass of an element or compound.
Okay. Actually, we might look at that today briefly. Inaki, please rename yourself. Rename yourself. It's not hard. Or at least tell us who you are. Inaki, you have 2 minutes to do so. Okay, let's get started. So a few weeks back, we looked at this relationship when we compare a mole in terms of mass, in terms of particles, and in terms of volume. So we discovered that for mass, for 1 mole of any given compound, the mass will always be equal to the relative formula mass of that compound. And we had a look at it. Then for particles, every mole of any substance, be it hydrogen, be it oxygen, be it calcium carbonate, will always contain this number of particles, 6.02 times 10 to the power 23 particles. And then volume of any gas will always occupy this at standard temperature and pressure. So we are going to build on this to try and solve a few questions. We shall start with question 1. We need to calculate the relative formula mass of each of the following compounds. Please do it as fast as you can. We shall start with calcium carbonate. Today we have quite a lot to cover. Calcium carbonate. Yes, Ethan, you're welcome. Calcium carbonate. If you can do all the 4 because we are going to move quite fast. There is something I would like us to look at. Vianney, are you giving it a try?
Yes, sir.
Yes, if you finish a given section, please you tell us your answer and we note it down. Yes, Muzal. Muzal, are you also with us?
So I'm done with the first one.
Yes, Muzal. Yes, Peter.
I'm done with the first one.
Yes, what do you get?
100.
Okay, first one, they are getting 100. We have carbonic acid. Yes, Jackson, please try out the following questions. We are trying to find the masses of these compounds. Mazali, we would like to hear from you.
Yeah, for carbonic acid, it shall be 12 plus
No, what's the final answer?
16.
Your final answer. Shall basically go with the final answer and you see. Raymond, please try out these questions as fast as you can.
60.
You have 60
It shall be
here.
60.
Okay.
60. For carbonic acid, it shall be 60.
Yes, I've noted it down. Thank you. 60. Yes, Mukisa, please try out at least C and D. Those who have just joined, you can try out C and D. If you're finding a challenge, please let me know so that we can guide you. At least from this point, you should be able to write the chemical formula of each of these compounds.
So B is carbonic acid is 62.
Yes, Ethan. Are you with us, Ethan? Please try them out and submit the values you are obtaining.
Teacher, the formula of hydrogen sulfide.
Okay, hydrogen sulfide. Hydrogen valence 1, sulfur valence 2. Hydrogen sulfide. Yes, so it's finished. Okay, let's go through part A, as maybe others are finishing C and D. So we have calcium carbonate. So that means when we start with calcium, we have 40. Calcium is 40. Plus carbon, we have 1 atom. Carbon is 12. Then plus oxygen, we have 3 atoms. Oxygen is 16, but there are 3 atoms. 16 times 3. So 16 times 3 is 48. 48 plus 12 is roughly 60. 60 plus 40, which is 100. So calcium carbonate, RFM is 100. Then we also have carbonic acid. Carbonic acid, the formula is H2CO3. So that means we have 2 hydrogen atoms. 2 times 1, or 1 times 2, which is 2. Plus carbon is 1 atom, or 12 times 1, which is 12. Plus oxygen, 16 times 3. 16 times 3 is 48.
48.
48 plus 12 is 60. 60 plus 2 is 62. So this one is out. Then we have hydrogen sulfide. 20?
34. It's 34. 34.
Yes. 2 from hydrogen, 1 times 2 plus 32. About iron-2 sulfate.
Sulfate.
Arinda, Mark, are you trying out part C and part D? Arinda and Raymond.
I got 88.
88. Okay. So others will find us on the way. Let's try out iron-2 sulfate. So we have iron-2 sulfate, SO4. Balance of iron is 2, balance of sulfate is 2. So the 2's cancel out. So this will mean that we have one atom of iron, which is 56, plus one atom of sulfur, which is 32, plus 4 atoms of oxygen, which will be 16 times 4. What do we get? 56 plus 32.
152. 152.
152, yes. So at least now we know how to calculate the relative formula mass of any given compound. And with that, it means that we can always find the mass of 1 mole of any compound, because the mass of a single mole of any compound will always be equal to the relative formula mass or the relative molecular mass. So let's look at something similar but a bit different. In this case, we are going to try to convert the number of moles into grams. In the other case, we are just finding the mass of a given compound. Now, what if you are given a given mass of a compound and you want to determine the number of moles? In this previous slide, we have seen that the relative formula mass is equal to 1 mole of a compound. But now, for example, in part A, 100 grams of calcium carbonate are equal to 1 mole of calcium carbonate. Yes, we are only looking at 1 mole for all these ones. Once we are finding the RFM, we are finding the mass of 1 mole. But now in this case, we are given masses. Maybe if you are given 50 grams of calcium carbonate, if you can somehow see it, it will be 0.5 of a mole, because it's half of 100 grams. So we are going to somehow work backwards and relate grams.
Mass out of mass of 1 mole.
Yes. So let us do part A together, then you will do B, C, and D. So from our previous question, we have seen that calcium carbonate, the mass of 1 mole is 100 grams. But now we want to know the number of moles in 246 grams. So I can say that 1 mole, okay, we can say 100 grams of calcium carbonate contain 1 mole. What about 240? Should we first do 1 gram? I don't know how easy it is for you. Should we start with 1 gram of calcium carbonate, or we can go directly to 246? Okay.
Let's start with 1.
So 1 gram of calcium carbonate will contain, what will it contain? Now this is some logic. Look at it in this perspective. For example, 100 pence cost 10,000 shillings. What about 1 pen? You'll always get this divided by that. 10,000 divided by 100. So in this case, we shall get
10.
Yes?
10.
Yeah, it will be 100. Huh? Right? Okay. It will be 100, isn't it? 1 pen will be costing 100. So if you look at this question here, 100 grams of calcium carbonate contain 1 mole. What about 1 gram of calcium carbonate? It will contain 1 mole divided by 100 grams. So it will be 1 over 100.
Wait.
So 1 gram of calcium carbonate will contain 0.01 moles, such that 100 of these will always go back to this 1 mole. Okay, let's repeat it once more. We have seen that. No, let's go back to calcium carbonate. If we are going to do part B and C, calcium carbonate, we have seen that 1 mole, okay, 1 mole of calcium carbonate weighs 100 grams. But now I prefer putting what we know on the left and what we don't know on the right, because we are going to calculate number of moles. So I can say that 100 grams of calcium carbonate contain 1 mole. Now, if 100 grams can contain 1 mole, what about a single gram? You'll have to divide 1 mole by 100. That's the only science you should be able to tell. I don't know how many people can get that concept, that if I'm to get 1 gram of calcium carbonate, I'll have to divide by 1 mole by 100. Please, if you are lost here, let me know. So 1 gram of calcium carbonate, okay, let us say moles, will contain 0.01 moles. Who's lost from this part? No one?
Sir, I understand. I understand.
Yes, Conan. Okay, Conan maybe is saying he's lost. So, okay, instead of using 100, let us say 20 students weigh 120 kilograms. What will be the weight of 1 student, assuming that they have equal weights or average weights? 1 student will weigh, we shall get the 120 divided by the total number of students.
20.
Yes, to get the 1 for 1 student, which will be 6, right? So it's the same thing here. 1 mole, 100 grams are containing this. The only thing that we're not using weighing, we are saying contains. Yes. Or let's look at it in this form. Maybe 4 streams contain 240 students. That means 1 stream on average will contain how many students? Will contain the total number of students divided by the number of streams, which will be 60 students. But now we are not using streams, we are using 100 grams containing 1 mole.
Oh, so I understand.
That means 1 gram will obviously contain 1 mole divided by the total number of grams, which will be 1 over 100, which will be 0.01 moles. So we're just relating 2 things.
Yes, I understand.
Yes. So hope Conan, you are with us now. So if 1 gram of calcium carbonate contains 0.01 moles, now what about the actual mass that they want us to find? So 246 grams of calcium carbonate will contain, what shall we get? What can we do here? Okay, Conan. So it will contain 0.01. If 1 gram is this, that means 256 will be times this, right? So it will be 0.01 times 246. What do we get?
I
think
So 2.46
Yes.
moles.
So the number of moles present in 246 grams of calcium carbonate will be 2.46 moles. So that's how we have done part A. So
Sir.
please, yes, please.
So if we know the mass of 1 mole of calcium carbonate, we have
Yes.
to find what is in one gram of calcium carbonate, right?
Yeah, that's what you
Then-
proposed. Yes.
Then the given mass that you have put, you multiply with the what? Number of moles in 1 gram.
Yes. Although you can skip, with time you'll be able to skip this step, but it's fine. You can first always find this step. So we have already finished finding the mass of calcium of carbonic acid from our previous slide here. It is 62, 34, 88. Okay. We shall not do double work. Here we have 62.
The
Here we
carbonic
have-
acid is 62.
Yes, here we have 34, 88. I think
34. Hydrogen sulfide is 34. Ion2
Yes.
sulfate is 152.
Okay, sorry. I don't know what I'm saying. Yes, 152. So let's try and find the number of moles in 100 grams of calcium carbonate if 1 mole contains 62 grams.
No, sir, carbonic acid.
Yes.
We have finished calcium carbonate.
Yeah, we're on carbonic acid.
Oh,
Yeah, carbonic acid. 100 grams of carbonic acid. Then we have 68 grams of hydrogen sulfide, 102 grams of. So we're on part B and part C and D. Champion, are we together?
Yes, teacher.
Please, if you are lost, you let me know so that I elaborate more. Yes, Matthew. Matthew, are we having the same wavelength? Kale Matthew, I want to hear from you. Batahinga is there? Yes, Isaiah, Batahinga. I want to hear from you as well to know that we are at par, otherwise mole concept will not be
Yes, sir.
as.
Okay.
Okay. Please, if something is challenging, you ask for guidance.
Okay, sir.
$62, 34. Okay, I'm going to erase what is on the screen, whatever I've written on the screen. Is it fine?
it's okay, sir.
62, 34, 52. Okay.
I'm done with B.
You are done with B. Okay, just a moment. Okay. What did you get on B?
I got 1.6 moles.
1.6 moles. Okay. Anyone having something different, share with us. Remember, for you to be able to do this, you must be able to do question 1 because the values I've given you come from question 1. 34.
So I can do now C.
Yeah, you do C and D. All of you should do all the 3. Actually, we had more to cover, but it seems Shall cover it next year, I guess. If this is the last lesson, I don't know.
Sir,
Yes?
do you know at number C, you can just guess? 32
Yeah,
times
because
2 is
68 is a factor of,
68
is a multiple of 34. So what do you think is the answer?
2 moles.
Are you sure you guessed it?
I saw I guessed it.
No, you didn't guess. Okay, then part D.
I was using logic.
Yeah, but logic is not guessing. Part D. Yeah, C is obvious if you can look at it and just tell. If 1 mole weighs 34, 68 grams will be equal to 2 moles. Klein, what are you obtaining? If you are with us, I am not certain. Vianney, what are you getting?
D is 0.7.
D is 0.7 moles. Okay, so 0.7. So we are going to do part D only. Probably
Now
we'll
wait
go
for
to.
me.
Yes?
Now wait for me.
We are going to do part D and probably go to question 3. So we know that 1 mole, we know that 102 grams of iron-2 sulfate contain 1 mole. Oh, sorry, it's 152. You people are not telling me. It's 152 grams, which contain 1 mole. So,
1 mole.
what about 1 gram of iron-2 sulfate? It will contain 152 moles. But now the mass we are having is 102. That means 102 grams of iron-2 sulfate will contain this number of moles times 102. What do we get? 102 divided by 152. Wow. Okay, 0 points. I don't know how I somehow.
0.67.
I don't know how I had
0.67.
somehow guessed the right one. Okay, if you round it off, it will be 0.7. So we get 0.67 moles. So actually, to me, this step, I don't normally use it, 1 gram, but we shall find ways of overcoming this
But
long.
why can't you just leave in this?
To me, it wastes time. If I can do without it, you know, because
No, sir, like just to get the, sir, I'm saying that, like just to get the mass, then divide it by the mass of 1 mole.
yeah, that's it exactly. So x0 is equal to 102 over 152. Yeah, it can work. Yeah, that's fine. Anyone who's lost, please tell us so that we continue. In your free time, maybe I'll send the slides and you try out B and C and see whether they are all correct.
So when?
Maybe after this lesson, I can send them to
Oh my God,
Google
yes.
Classroom, but the annotations will be removed. And please let me know if PDF is better or PowerPoint.
Yeah, PDF is better.
Okay, let us go to question 3. How do you get 152 grams? Yeah, someone's asking how do you get 152 grams? Now, 152 grams from question 1, it was the RFM of iron-2 sulfate. Someone was asking how you got 152 grams. So iron-2 sulfate, this was the formula. And when we try to calculate the total mass of all the elements present, we got 152, which is here. So it was getting it from the RFM, which is the mass of 1 mole. So that's how we got 152. So that was from question 1, if you were not with us. Okay, so 152 came from question 1. The same applies to 34 grams, came from question 1. So now, when you look at our first slide here, we said that 1 mole of any gas will always occupy a certain volume. Yes? Okay, I don't need to go back. 1 mole of any gas occupies 22.4 liters at STP. You remember that assumption?
Yes.
So in question 3, we are going to find the volume occupied by a certain number of moles of any of the following gases. So for example, I'm going to do part A, you do C and B. 1 mole of hydrogen gas, 1 mole of hydrogen gas is equal to 22.4 liters, which is the
The
same
answer
as,
is 44.8 liters.
yes, that means 2 moles of hydrogen gas will occupy which volume? 2 times 22,
44.8.
which is 44.8 liters, which is the same as 44,800 cubic centimeters. Let me hope all of you know that 1 liter is equal to 1,000 cubic
1,000
centimeters.
liters.
Yes, so that's how we have done part B, part A, and we obtained the volume being occupied by 2 moles of hydrogen will be 44.8. Can you try and find out the volume occupied by 0.4 moles of carbon dioxide and 3.4 moles of ammonia? In this case, you don't need to find RFM, you just need to relate, because we know that 1 mole of any gas occupies this irrespective of the mass of that compound. So B and C I use, I've done for you A. So try and do it in less than 10 minutes because we have less than 10. 0.4 moles of carbon dioxide. Yeah, still you'll discover that there is a pattern. Sometimes you will not need to do all this working. Yes, what do you get?
8.96 liters.
8.96
B.
liters, okay. Kalule Matthew, what are you getting for C?
Saffron C.
Yes, Peter.
It's 76.116 liters.
Are you guessing or you are cheating? It is 6 point?
No, 76.
76.16
liters. So I'm done.
Okay, let's wait for our colleagues and see that they are getting the same thing. Fauzan, are we at par? Yes? Yes, colleagues, please let me know. If you know that 1 mole occupies this, what about these moles, you know? Just have
Let's
to
multiply all of them. Let's multiply 0.4 moles times 22.4.
Yes, Mokisa, are we together? Dumba, are you in the lost city of gold right now? Or you are with us?
Sir.
Yes.
B is 89,600 cubic centimeters.
Okay. This is also 8,000. Okay. Good.
And C is 761. No, it's 660 centimeters.
Guys, are we able to obtain the same values as Peter 8.9 and 76.2? Okay, let's do only part B, and then Probably we can go to something else, I don't know. Let's do part B. Okay, I'm going to erase part B answers roughly.
Yes, teacher.
Part B answer is 8.9.
Roughly 9.
Yes, so if 1 mole of carbon dioxide occupies, I'm not going to write that occupies 22.4 liters. What about 0.4 moles of carbon dioxide? They will obviously occupy 0.4 times 24, 22.4 divided by 1. So that they will occupy 0.4 times 22.4 divided by 1. And the answer you get was the one he got, liters. Yes, the moles will cancel out.
8.96 liters.
The moles from the 0.4 will cancel out with the moles with the 1. Then we shall be left with the units of liters on the 22.4. So in your free time, you will try this out. How I wish we had
Yes,
more
I'm
time.
done. I'm done. Mark me 100.
Maybe for question 4, maybe you probably try it out on your own. It's the other way around. We have just kind of flipped the
Hey,
side
sir,
we are
wait, I can
asking.
try it now.
Yes.
So I can try
So
it
in
now.
this case, they give you liters and you need to know how many moles are in those liters. So how I wish we had time, but I could have loved us to go to analyze equations, but
Sir, number,
okay,
I mean, A is.
let's end with
sir, A
this.
is 8.5.
Let's end with question 4. At least we do one.
Sir, A is 5.5 moles.
Let's try and do at least one question from question 4. You have said it is 1 point.
No, it's 5.5 moles.
You see, Peter should tell you his guessing techniques.
No, I'm not guessing.
Determine the number of moles that occupy 44.8 liters of carbon dioxide.
2 moles.
We are going to do one, probably if we meet again, we shall try out.
Like 0.5 moles, that one.
We
Number
shall learn
6.
how to analyze equations so that we can use the theory we are getting right now. 0.5. Okay. Yeah, for B and C, if you're good at analyzing, you can somehow tell, because these ones are either factors or multiples of 22.4. But when you look at part A, let's do part A. Let's do part A. So for part A, we know that 22.4 liters of hydrogen are equal to 1 mole or contain 1 mole. Now, what about the 124? I'll not do 1 liter. I'll not do 1 liter. I not want 1 liter. This will be equal to, of hydrogen will be equal to 124 times 1 over 22.4. Okay, we shall get time and go through question 4, just that maybe we are short of time. That's why I'm trying to go through shortcuts, but they're not healthy. So don't worry about question 4. For those who have seen the pattern, it's fine, as long as we arrive to the same answer. So we shall stop here unless you have a question. Please, you can ask. But see, when I see you, I'll send some of these slides minus this part of analyzing equations. We have a lot to cover here.
Sir.
Yes, please.
So give me an equation and I find the number of moles.
We are short of time, unfortunately. Guys, see you. I'm going to try and compile and send to Go Classroom. Bye-bye.
Bye, teacher.
Okay. Those who came late, we shall always keep